Learning Outcome 2, Algebra and Equations, 11.2.5b. Solve equations in two unknowns, one of which is linear and one of which is quadratic, algebraically or graphically.
Hi, Miss.
Hi, Deboho. What are you working on today?
I'm busy with graph interpretations. I was doing pretty well until I got to this question here. It says I need to find the points of intersection of the two graphs. But I have no idea how to do that.
Well, to do that, you would have to solve the equation simultaneously.
But how do I do that?
Well, I can show you if you like.
Oh, that would be great. Thank you.
By the end of this lesson, you should be able to solve simultaneous equations algebraically and graphically. All right, here's a set of equations we can work with. As I said earlier, if you want to find an intersection between two graphs, you will need to solve the equations simultaneously. There are two ways of doing this. Do you have any ideas what those two ways could be?
Wow, since all the equations are graphs, if we sketch the graphs accurately on graph paper, we should be able to read the answers off the graph.
That's right. We can solve simultaneous equations graphically. Let's start with that. Can you tell me what our first step would be?
Well, to start off with, we need to write the equation with y as the subject of the equation.
Why don't you go ahead and do that?
Okay, that's pretty easy. To isolate the y in the first equation, I need to move the x squared and the 9 to the other side of the equal sign. So that gives me y equals x squared minus 9. For the second equation, I need to move the 3x and the minus 9. When I do that, I get y equals minus 3x plus 9. There we go.
What do we do next?
Well, we need to draw a set of axes and then plot the graph.
That's right. Let me save you some time. I have a set of axes already drawn up that you can use.
Oh, thanks. That will really save time. Now all I have to do is work out the plotting points on the graph and then we can sketch it.
Do you have to do that for both graphs?
Not really. This equation here is the equation of a linear function. To draw it accurately, I only have to find the x and the y-intercepts and then join them with the ruler.
All right. Why don't you go ahead and do that?
To find the x-intercept, we need to make the y equal to 0 and solve for x. So the x-intercept is 3. To find the y-intercept, we need to make x equal to 0 and solve for y, which makes the y-intercept 9. Now I plot the intercepts on the axes. X equals 3 is here, and y equals 9 is here. Now all I need to do is join them with my ruler.
Well done, Deboho. Now, what about the quadratic equation?
I'll have to plot the quadratic if I want the graph to be accurate. Do I need to substitute the values of x into the equation to find the y parts of the coordinates and then plot each point? I'll start with x equals 8 and go up to x equals negative 8. So, if x equals 8, then y equals 55, which means the coordinate is 855. I'll plot that on the graph. 855 is here.
Good. Carry on.
Okay, I've plotted all the points. Now all I need to do is join the points to draw the graph.
Very well done, Deboho. Can you read off the points of intersection?
Yes, the graph intersects here at negative 6, 27, and here at 3, 0.
Good. Now all you need to do is write down your answer then.
Okay. For the first solution, x equals negative 6 and y equals 27. For the second solution, x equals 3 and y equals 0.
Very well done. Now that wasn't so hard, was it?
Nope.
Why don't you try this one on your own? Let's move on to solving equations algebraically. We'll use the same problem as before so that we can compare our answers. Let's have a look at the graph you just drew for a second. Would you agree that at these points here, where the graphs intersect, the coordinates are the same on the straight line and on the parabola? In other words, this point lies on both of the graphs.
Yes, I agree with that.
Okay, so we could say with certainty that at the points of intersection, the values of x and y are the same.
Yes.
Which means that the y in this equation is the same as y in this equation. Similarly, the x in this equation is the same as the x in this equation. Which means if I substituted the y value of the linear equation for the y value of the quadratic equation, I would not be changing anything in this equation.
I can see the logic behind that.
Good. And by the way, this method is called solving equations simultaneously. Now, do you think you could do that for me?
Yes, I can. Okay, I'll call this equation 1 and this equation 2. The y values are already the subject of the formula, so all I need to do is substitute. In equation 1, y is equal to minus 3x plus 9. So I put the value here where I see y in equation 2. Hold on a sec, there are no y values now. Is that right?
Yes, it is, Deboho. By substituting, we eliminate one of the unknowns, in this case, y. This means that we are only left with one unknown, so it will be easy to solve the equation.
That's really clever. I think I can solve this now.
Go ahead.
First, I need to move everything to one side of the equation. Now, I factorize the trinomials and solve for x. So, x equals negative 6 or positive 3. There we go, all done.
Very good, Deboho. But are you sure you finished?
I think so.
Why don't you compare your algebraic solution to the solution you found graphically?
Okay, the values for x are the same. Oh, I see what you were saying. I haven't found the solutions for y algebraically yet. But how do we find the values for y?
Well, you substituted y from equation 1 into equation 2 to find the values of x. So all you need to do to find the values of y and substitute your answers back into equation 1 in order to find y. Do you think you can do that?
Sure, it shouldn't be too hard. I'll take the first solution, x equals negative 6, and substitute it for x in equation 1. And then solve for y, which gives me that y is equal to 27. Then I substitute x equals 3 into equation 1, and I get that y is equal to 0. So the solutions are x equals negative 6 and y equals 27, and x equals 3 and y equals 0.
Very well done. Now you know how to solve equations simultaneously, which is the same as finding the points of intersection of two graphs. Remember that the graphical method is less accurate than solving simultaneously. I suggest that you always use simultaneous equations when solving for points of intersection unless the question instructs you to use the graphical method.
Yes, thanks to your help.
Here is an example for you to try on your own.